Okay, so I've come up here. Oh, you know what? We did x's. I accidentally typed in the y's. So I'm just plotting what, using Mathematica, what our equation looks like. 1/4 13 plus x plus the square root of 25 minus x squared, as x goes from 0 to 5. And we found some solutions. When x is 3, this must be 5.
And then
when x equals 4, this must be 5. But it's also telling us that x equals 0, we had 4.5. And remember we said that actually can't work, right?
yeah.
But it does produce a number. But we knew that number, how did we know that didn't work?
Well, because of how it had to be oriented, the line segment that was connecting the two sides together actually had to be on the side.
Okay.
It had to be less than or equal to that side.
Ah, okay.
So unfortunately, it's not. It was bigger than the side.
All right, so this is the side length. So maybe what we want to do is subtract away x from this, because that'll be one of the sides of the triangle. So this will have to be positive, right?
Yeah.
So we see it's not always positive. So it doesn't.
Dips below.
It dips below. At some number up here, this dips below. Should we try to find out what that number is? Maybe we can zoom in. Do you have any guesses what that number is between 4 and 5?
4.8, I think.
Looks like 4.8. Okay, so I'll go from 4.6 maybe to 4.9.
Okay.
Hey.
Yeah, almost
Exactly 4.8.
Might be exactly 4.8. Okay. That's interesting. So, what do we get when we get a side length? When x is 4.8, we get 1/4 13 plus 4.8 plus
14.
Oh, sorry. 13 plus 4.8 plus the square root of 25 minus 4.8 squared. Is that what we want?
4.8.
Here we get 4.8.
Sounds good.
So that's interesting. So we get exactly, that's an interesting bit of symmetry. So we get one side is 4.8 of the triangle. The hypotenuse is 5. Am I on screen down here?
Just barely. Yeah.
Barely. Okay. I get the hypotenuse is 5, one side is 4.8.
Yeah. So, that's too big.
Now it means the other side is actually 1.4. This is a 7, 24, 25 triangle.
Cool.
Just multiplied by 2, or multiplied by 0.2.
1/5.
Yeah. So that's actually neat. So the other side I said is what,
1.4.
1.4. So you can imagine going around the square. We're touching the square at the top. So we go 4.8, 4.8. That's 9.6. And then I have to go across until I hit something that's 1.4. So that's going to be 3.4 away. So 9.6 plus 3.4 is?
13.
13. Okay, so there we go. So that's interesting. And then the other thing is that the square root of 25 minus x squared has to make this positive as well, right?
Yeah.
When I subtract away the square root of 25 minus x squared, now it still has to be positive. I have to go back going from 0 to 5. And it looks like it crosses somewhere around here.
1.2 maybe?
Oh, let's see. It doesn't look like 1.2 to me, but first let me go from just 1 to 2.
Oh, 1.4.
Let's go from 1.3 to 1.5.
Yep.
think it's exactly 1.4. 39. I just can't tell. I'm too far away. I'm gonna go from 1.39 to 1.41.
Yeah.
Hmm.
So that's
Exactly.
pretty exact.
Looks pretty exact. Okay, but we already know what works there. That's just our other triangle reversed, right?
Yeah.
Yeah.
So it looks like we've got to do our original plot. Going from 1.4 to, what was it, 4.8?
4.8, yeah.
Did I miss? Looks like I left in a stray bracket there. Here we go.
Cool.
And this tells me the side length. And then maybe there'd be some very clever way we could find what the maximum value is. It looks like it's actually a little bit bigger than 5, right? But it certainly looks like it's between 3 and 4. So let's zoom in here. 3, 4.
So it's like 5.2, little less maybe.
Well, it's okay. So we can go from 3.4 to 3.6 and maybe zoom in just a hair more.
You did 3.6.
It's alright, they found the maximum.
Alright.
So it's a little bit below 5.2, but maybe we could. We'd have to use calculus to find it. But we found that these side lengths actually all work.
Yeah.
The maximum perimeter is actually a little bit bigger than 20. So this shows a solution that where the side length is not 5. So it turns out this does not uniquely determine our triangle or our square. I mean, which is pretty neat.
Yep.
Yeah.
All right, good work tonight, guys.